Hello to all, welcome to the channel Money's Gate Tech Vision. In this lecture, I am going to solve GATE 2022 problems in the discipline of electrical engineering from the subject electric circuits. The topic which I have taken is common for EE, electrical, electronics and instrumentation. So all the students can view this lecture. I will solve the problem. First problem is, in the circuit shown below, the magnitude of the voltage V1 in volts across the 8 kilo ohms resistor is dash. This is one of the numerical answer type question. So here one circuit is given. It consists of three sources. One is independent voltage source 75 volt, independent voltage source 75 volt, and this is dependent voltage source which is given as 0.51, and this is dependent current source. So this is dependent voltage source and this one is dependent current source. So for the dependent voltage source they have given us 0.5 V1. That means it dependent on the voltage which is V1 across 8 kilo ohms. And here for the dependent current source I is given, which is the current flowing through 2 kilo ohms. Okay, we need to find out V1 which is across 8 kilo ohms. We need to find out V1 voltage. So the topic is network and solution methods. We can solve the problem. By using Kirchhoff's voltage law, we can write the equation. I am taking this as loop 1 and this is loop 2. So I am going to write the equation for two loops. First loop, taking the first loop, it consists of two sources, two voltage source. So we can take the Kirchhoff's voltage law. Sum of voltage drop equal to sum of voltage rise. So this is negative to positive potential. So we can represent it as positive 75. And here positive to negative potential, when the current flowing through this direction, we can take this positive to negative potential. So we can take the voltage as negative voltage. So 75 minus 0.5 V1 equals, what is the voltage drop? 2 kilo ohms into I. Okay, so 2 into I. I is the current flowing in this loop. So for loop 1, I have written the equation by using KVL. 2I equals 75 minus 0.5 V1. Okay. See the loop 2. I is given, V1 is given, resistance is given. So directly we can write the equation by using Ohm's law. So by using Ohm's law, we can write as V equal to IR. V1 equals I into R is the resistance 8 kilo ohms. So V equals 8 into I. V1 equals 8 into I. From this we can find out the current I is V1 by 8. Now I am going to substitute this I in the first loop equation. So substituting I in first loop equation, 2 into V1 by 8 equals 75 minus 0.5 V1. So from this we can find out V1 as 300 minus 2 V1. And from this we can solve for V1 as 300 by 3, which is equal to 100 volt. So we found V1 across 8 kilo ohms as 100 volt. Answer is 100 volt. Voltage across 8 kilo ohms is 100 volt. Okay. Let me go to this problem. This problem number 2. It is given from the topic RC transients or time domain analysis of RC network. So here I will read the problem. In the circuit shown below, the switch S is closed at t equal to 0. Switch S is closed at t equal to 0. The magnitude of the steady state voltage in volts across 6 ohms resistor is dash. Round off to 2 decimal places. This is also one of the numerical answer type question. So here switch S is going to be closed at t equal to 0. So initial condition is switch is opened. Switch opened condition is the initial condition. And here during the steady state condition, we need to find out the voltage across 6 ohms. Voltage across 6 ohms. So let me solve for the problem. Before switching condition, when switch S is opened. So when switch S is opened, what will be the condition? When switch S is opened, we can discard this whole part. So the circuit will become like this. There will be no voltage source. Now we need to find out the voltage across 6 ohms. So there will be no voltage source. Then voltage across 6 ohms is automatically equal to 0. Voltage across 6 ohms is nothing but voltage across a capacitor, that is equal to 0 only. Vc of 0 minus and Vc of 0 plus equal to 0. Okay. So, and after switching condition, when it attains the steady state condition, after switch S is closed, at one time it attains the steady state condition. That is at t equal to infinity, the circuit RC transient circuit attains the steady state condition. During the steady state condition, this RC transient network, RC network will act like a DC network only, and capacitor can be open circuited. Why it has to be open circuited means during the steady state condition, the current will be current through the capacitor will be equal to 0. From the derivation, you can find out that current through the capacitor will be equal to 0. So we can open circuit the capacitor during the steady state condition. To find out the steady state voltage, we can open circuit the capacitor. So after open circuiting, the circuit will become like this. So now we need to find out the voltage across 6 ohms. So what is the voltage across 6 ohms? In parallel condition, voltage will be same. So voltage across 6 ohms will be equal to voltage across 3 ohms will be equal to voltage across 2 ohms. So by voltage division rule, see here, we can discard this. We can discard this whole branch. We can cross out this. So only 6 ohms parallel with 3 ohms parallel with 2 ohms and total voltage is 10 volt. So we can use voltage division rule to find out the voltage across 6 ohms. Voltage across 6 ohms is nothing but voltage across 2 ohms. So by voltage division rule, we can find out the branch voltage. We can find out the voltage across 6 ohms. It is nothing but 10 total voltage into 2, that resistance by total resistance. Total resistance is 4. 4 means 2 parallel with the parallel circuit of 6 and 3. So by equating the parallel condition, 6 into 3 by 6 plus 3, 18 by 9 is 2. So 2 and this 2 ohms is the opposite resistance. So 2 plus 2, 4. So 10 into 2 by 4, which is equal to 5 volt. So we found voltage across 6 ohms during the steady state condition. Okay. So answer is 5 volt. Steady state voltage across 6 ohms resistor is 5 volt. Thus we found the answer for the question. This is Mani's Gate Tech Vision. This is a channel for engineering competitive examinations. You can subscribe to my channel. You can view the lecture series regularly. You can mail to me. You can clear your doubts also. Thank you very much for watching the video. Thank you.